Record. All right, welcome to AP Chemistry. It's good to have you here. So we're looking at Unit 1.2, and our learning objective here is to explain the quantitative relationship between the mass spectrum of an element and the masses of the element's isotopes. So there's some key terms here that we probably need to be familiar with. One would be an isotope, right? Do we remember when we talked about isotopes before? Isotopes, and we're going to define these here in just a second, they are atoms of the same element, but they have different mass numbers due to having a different number or a varying number of neutrons. All right. Now, we see that term isotope, but then we also see mass spectrum. And so we end up getting what we call a mass spectrum from a mass spectrometer. And what happens is they put a sample of atoms into a mass spectrometer, and the isotopes are separated by mass. They are essentially counted, and we can determine what percentage of each isotope we have. And then we take that data and we can determine what the average atomic mass of all the isotopes that exist for an element is, right? And then we have that information on our periodic table. So we see on our periodic table the average atomic mass, right? And this is where this comes from. And so what we're going to be looking at here is just explaining this relationship between mass spectrum of an element and the masses of the element's isotopes. So we're going to see that relationship. And basically, it's going to look like what we call a weighted average. So let's first look at our essential question here, and we see what information can be determined from the mass spectrum data of an element, and what information is used to determine the average atomic mass of an element. So here I'm starting off with an example, all right? And I also ask a little sub question here: what information can be determined from the isotopic symbol? So I'm going to write the isotopic symbol, and we're going to talk about isotopes at the same time. So here, this has three isotopes identified in, or this one isotope, but of three different ones of the same element. So we have iodine is 80% I-127, 17% I-126, and 3% I-128. Now I'm going to write these in order of their atomic mass and not the percentages. Here it's written in order of their percentages. I'm going to write it in terms of their mass. So we have I-126, we have I-127, and we have I-128, right? So these are our three isotopes. Notice they are all iodine, right? So they are all atoms of the same element. Now, when we have an isotopic symbol, here's an isotopic symbol for element X, we put up here the mass number, and in the bottom, we put the atomic number. Right? Now, what is used to determine the mass number? The number of what? Protons plus the number of neutrons. All right? And then what is the atomic number? What is that? It's only the number of protons. Do you see that? So, how can we determine the number of neutrons from an isotopic symbol? We take the mass number minus the atomic number, and that would give us the number of neutrons. Do you see that? And so this is stuff that we should already know, right, from last year. And so that's stuff we should just know. So now we see these three isotopes. They're all iodine. That means, what is defining iodine? What is the one subatomic particle that is defining iodine? Go ahead. The number of protons. So how many protons does iodine have? How many protons does iodine have? Look at your periodic table. Find the atomic number of iodine. Yeah, go ahead. It's 53. So each of these have 53 protons. It's the 53 that is defining these as iodine. But notice they have a different mass number, right? The mass number changes. The only reason the mass number changes, it's not because of the number of protons, but it's because of the number of neutrons. Do you see that in that equation? So isotopes, once again, atoms of the same element. These are all isotopes of iodine. They're all iodine. They all have 53 protons, but they have different mass numbers because each of them have a different number of neutrons. Now, if you get your handy dandy calculator out, how many neutrons does isotope I-126 have? So this one has 73 neutrons. Anyone disagree? This one would have then what? 74 neutrons, and this one would have what? 75 neutrons. Do you see how they have a different number of neutrons? 53 plus 73, 53 plus 74, 53 plus 75. Did I make that abundantly clear that these are isotopes and how we get that? All right. Do we understand how to read an isotopic symbol? When you have an element that up in the top left corner that's representing, that number represents what? The mass number. The mass number is the number of protons and neutrons. And then in the bottom left, that would be the atomic number representing the number of protons. You need to make sure you know that. Other ways that these are symbolized. It could be symbolized as I-126, I-127. Do you understand what that means? That's iodine with a mass number of 126, iodine with a mass number of 127. You see that? There's several ways that these are indicated. They're not super difficult to determine. All right. The next thing, it says to show an example calculation for calculating average atomic mass. Now, when we take an average, when we're dealing with isotopes, we're not just taking a straight average. We're not going to just say that we have, 3 isotopes, I-126, I-127, and I-128, add those values up and divide by 3. That's not how these averages work. These are a weighted average based on the percentage of each isotope found in nature. Do you see that? So it is based on, it's weighted based on its percentage found in nature. So we're going to use this data that we have right here at the beginning. We see it says iodine 127 is 80%. Well, let's start with 126. We'll just use the same data. So we have, I'm going to start, it doesn't matter what order I put these in, but let's say I-126. And so what we notice is the atomic mass is 126 AMU, atomic mass units. And what we're going to then do, so we're going to put the mass number, and then we're going to multiply this by percentage in decimal form, or percentage as a decimal. So if I want to take 17%, how do I express that as a decimal? I take 17 and I do what? Divide by 100. And I would get what? 0.17. All right? And so I'm going to get some value here. I don't know what that value is. 126 times 0.17, and we get 21.42. Anyone disagree? AMU, atomic mass units. We're going to do the same thing for 127. Now 127, we have 120. Well, there you go. I wrote down the wrong number. 127 AMU. And what's the percentage? What does it say the percentage is? 80. You do not have to figure out these percentages. That information is going to have to be given to you. The only way you would know how to figure that out is if you had a mass spectrometer and you took a sample of iodine and you ran it through there and you had it calculated for you. There's no way you're going to determine that there's 80% of isotope I-127. You understand? Other than running a mass spectrometer. So in no way are you expected to know that information. It has to be given to you. It has to be. So this is going to be, what is 80% as a decimal? This should be abundantly easy now, right? Real easy. 0.80. So what do we get there? 101. Well, there you go. I can't write. 101.6 AMU. And then we do the next thing for 128. And so 128 AMU times, what is 3%? You understand where I'm getting 3%? It says it right there. 3% expressed as a decimal is what? 0.03. And that becomes what? 3.84. So you see how this 3%, it gives you a very small number, right? All right, so is that 128? Is that isotope 128 contributing a lot to the overall mass? No, because there's not very much of it, right? There's only 3% is 128. So now what we do is we add these values up. And so when we add these values up, we should get, I don't know what we get. We'll see. 101.6. There we go. We get 126.86. Is that what y'all got? 126.86. All right, now that should be something very similar to what you have on your periodic table for iodine. Now, what we have here on our periodic table, at least the one on this board, I don't know what it says on your one for AP, but it says 126.90. What could be the difference here? They probably just didn't give us maybe correct data, right? Or it's just that sample. It was really close to what the accepted value is, but nonetheless, it's something really close to what we see on the periodic table, right? And so you could even make a point to say that that rounds to 126.9, right? And then we have to make sure we put a unit AMU. So that's how we get the average atomic mass from isotopic data, all right? That's how we get that. So we got the percentages, and now we took the weighted average, and you see how that relates to the average atomic mass found on the periodic table. Now, if you're doing a multiple choice test, this isn't necessary, all right? You might not have to make this calculation at all on your AP test, but then again, you might, and it would be in the free response section, and it would be the easiest points you could ever get, right? Because that is one easy calculation, right? And I've seen it on the free response. So I make sure that you know how to do this step, all right? It is important to know how to do that. If they ask you to show how they got that, this is how you show that. Don't do it another way. Spell it out for them. I know how to do this, all right? So I'm going to expect you to know how to do this for my test and so on. So make sure you know that. But I give it a very small chance that you see that we have to do this specific calculation on your test. But is it a possibility? Absolutely, it's a possibility. More likely, and you will probably see several of these on your multiple choice section, this without a doubt you will see, all right? There is no doubt in my mind you're going to see this next part. So how can I determine, I guess average did not come out, the average, how can you determine the average atomic mass of an element using mass spectrum data? So notice we got a graph and it's telling us relative abundance percent, and that's on the y-axis. And then on the x-axis, you will have something like mass number, or it will say, yeah, it will say like mass number or something of that nature. And you can definitely tell what isotope you have there. So here we had 126, 127, and 128. Got ahead of myself. 128. And so we just simply are going to put in our peaks for this. So we have 126 has 17%. So I'll just draw that, and above it, I'll put 17%. So it's very clear to my grader what I'm drawing. 127, I'll put at 80%, 80%. That way they know, and then 3%. Do you see how easy it was to draw an average atomic a mass spectrum from that data? You may be asked to do that. That's easy to do, right? Again, that would be on a free response. More importantly, they're going to ask you questions about these graphs, all right, about the mass spectrum. They're going to ask you questions about it. What kind of questions are they going to ask you? Well, some of them are real easy. A real easy question would be just look at the graph. How many isotopes, according to this mass spectrum, how many isotopes of iodine exist? 3. How did you know that? There's 3 peaks, and so there's 3 isotopes. Look how easy that was. This test is not that bad. We should all be passing the AP exam. You see that? Do y'all know that? You all already knew that walking in today, most of you. All right, most of you knew that. We talked about that last year. So that's not too bad. Another thing is you might be asked to determine what is the average atomic mass of this using this data, right? Now, can you go do this calculation? Can you do that calculation and be successful on your test? Yes. Yes. Are you going to be really slow at it? Yes. Yes. So we got to have a different way of doing this. All right. We can't be slow. We can actually answer this, especially if it's multiple choice, in less than probably 5 seconds. All right. If we're being honest, in less than 5 seconds, you can do that same calculation if you're given this graph. So we're going to talk about how to do that. So we look at, in this case, we have these three peaks. And what I'm always going to do is I'm always going to look for the middle value, not just the middle number, but the middle value, right? So because not always are they going to be sequential, all right? In this case, they are. But you see how it 126, 127, 128. Now, if we took the normal average of this range, where would it be? 127, that's what you're looking for, the normal average. That's when I say the middle part, right? That would be your normal average. So if we took the normal average, it would be 127. But this is not a normal average. It's a what? Weighted average. Now, look, if you look at this part of this graph, you can think of like this being like a seesaw, right? Now, which way would this seesaw tip? If we let's see if I can draw something like we have a seesaw. Which way is it going to tip? It's going to tip towards 126 because that side is a little bit heavier. They're 17%. So what you know is the average atomic mass is what? Less than 127. Do you see that? You automatically. So if you had a choice that said 127.5 and 128, those choices can be eliminated right now. Do you see that? The other choice might be 126 or 126.8 or 126.7, 126.9, right? They're going to give you actual values like that work. But what we're doing is we're estimating, right? Where is it going to be? If they told you that it was going to be 126, does that make sense? No. Is that going to lean? Is this going to average going to shift to be all the way to 126? No. No. It's going to shift to be just a little bit from the normal average is what I mean by shift. It's going to shift away from the normal average to be slightly less than 127. So you're going to find the choice that is slightly less than 127. And there's going to be one glaring choice. All right? It's going to be very obvious. It's like, that's not it. That's not it. That's it. Boom. You're done that quick. Do you see that? Do you have to actually know what the specific value is? Well, you will know because there's only so many choices, right? And you're going to choose the one that's closest to the one you're thinking based off of this strategy. You see that? And you take seconds. I'm telling you, you can answer these in 5 seconds and move on. This is low-hanging fruit. This is the stuff that you need to get right because there's going to be much harder stuff than this. All right? And this is your path to passing. All right? And path to mastering this. All right? Global. Yes, we're going to take over the globe. All right? We should have nobody miss questions on this topic. All right? We should be the best in the world. Global. All right, exactly. It said, this is another. So let's look at this one. So it says, how can I identify an atom using the mass spectrum? So I want to identify what element I have here. Do you see this? Now, there is some big honking clues on this. Notice look what the mass numbers are. 75, 76, 77. Now I'm going to take you to the periodic table, and I want you to find 75, 76, 77. Where do we find elements? Okay, so right now, you can probably identify this element, right? Somewhere over here, 75, 76, 77. But actually, this is not, maybe it's not even a real element. So I don't know how you're going to identify it. Maybe, so it looks like it could be a real element, but it's element X. And I put element X for a reason because I don't want, on some of these, I don't want you to. But I do want you to maybe identify the But you understand you can just find the range and identify what element it could be. Here, I don't think we're going to get there. But and this is just one I made up. All right, I just put this in Excel and made this up. But what we see is we have a mass number of 75, 76, 77. And if I said, well, what is the average atomic mass of this element? All right, what is the average atomic mass of this element? Can we do that? Where are we going to look for first? What are we going to look for first? The middle value, or what would be the normal average, right? The middle value or the normal average. The normal average would be what? 76. So now, which way is this going to shift from the normal average? It's going to shift towards 77. Now, look at the difference between the peak at 77 and the peak at 75. Is it much larger? It's much larger. So it should shift, about halfway maybe. Do you see that? And again, it's an estimation. So I might say my estimation is 76.5. What if the next choice on your test was 76.6, and then your other choice was 77 and 75 or 75.5? Did you have a choice that is right there within range of what you would guess? Yeah. So you choose it, because you don't get to choose a choice that's not there, right? It's pretty easy, right? And so this makes your answer in your question much faster. All right. Does it mean are we somehow skipping over a knowledge base that we need to know? No, we're just using the math that we already know, and we're just applying it in a quicker manner so that we can get that done. All right. And that's what it is. Do we know how to take a weighted average? Yes. Are we still applying weighted averages to this? Absolutely. If this didn't have a larger peak than that, we wouldn't shift it towards 77. Do you see that? But it does. All right. And for those of you that didn't just see me point to the board, if this didn't have a larger peak than that, then we wouldn't shift it towards 77. All right. So there's an example. So we could say that this is X. What would we want to say? X what? X dash 76. And actually we don't, that's not true. It's not an isotope. We're getting the average mass. So we could say the average is equal to 76.5 AMU, right? Do you see what I'm saying? So we could say the average of element X is 76.5. Now, is there an element on here that has an average of 76.5? No, this is some fictitious element that I just made up. All right, so it's just that's what that is. All right, but you got 76.465. Oh, you got 77. Well, let me see. Well, hold on. How'd you get 77? I don't know what I just did there. Hold on.
Probably just because we estimated
Where is it? No, there's no way you're going to get 77. 77 would be too much. 70, you can't get an average of 77 from that. Yeah. It's going to be somewhere between, it has to be somewhere between 76 and 77. It's not going to be 77. Okay. Yeah. I thought maybe I wrote down the wrong value when you said that. That's why I said, let me check. But yeah, there's no way that you're getting 77. All right. Not from this graph. All right. All right. Let's look at another one. Oh, this one is fun. I like this one. Again, these are maybe a little fictitious. I'm just trying to go over like how we read these, right? So we could determine an average. Does that make sense? All right. So let's look at this one. By the way, let's ask a really easy question. How many isotopes do we have for this element? 5. How do you know? 5 peaks. Oh my goodness, this is tough. All right, now, hold on. Somebody made a mistake here. That should say 46. Okay, so there's not 2 45s. Okay, so who did that? All right, so what would be our normal average from this range? It would be 47. Now, what do you notice on either side of 47? Yeah, the peaks are going to be the same, all right? 2 away from 47 have the same average. 1 away from 47 have the same percentage, right? And so what does that mean? Which way is this going to shift from the normal average? It's not going to shift away from the normal average. The average is going to be what? 47 AMU. So you see how you read that? All right. Again, this is not to say that there is an element with an average atomic mass of 47. There may not be. Again, I'm just trying to teach us how to do this. You see how there's not one with 47? So it's some type of fictitious element. If it was a real element, we would find, and we said, oh, we're estimating that maybe our estimation is it's 47.6. We're going to like, whoa, it's probably titanium. All right. But 47, that's not going to do it. All right. It's way off. This is some fictitious element that I've made up. Just a futile exercise in reading the average atomic mass from the mass spectrum data. All right. And if you can do that, I don't know what this is doing. If you can do that, then you're going to be a go on any question they throw at you related to this topic. All right, you're going to be a go. It's going to be way too easy for you. So if we look at example number 3, what happened here? All right, so we have 17, 18, 19, 20, 21. How many isotopes do we have here? We have 4 isotopes. All right, 4 peaks. There's no peak at 19. What does that tell you? How many isotopes of X19 exist? 0. Wow, that was a hard question too, wasn't it? So there are no isotopes of X19. So where would we find our normal average from this range? At 19. All right, there's our normal average. Now, which way is this going to shift? It's going to shift towards 18. Really kind of hard towards 18, right? Really kind of hard towards 18. So I would say the 17 and the 21 are kind of canceling each other. Do you see that? And so then it's between 18 and 20. It looks like it's shifting hard. I would say 18.2 if it were me guessing. Do you see that? So I would say somewhere around 18.2 AMU. And then I would go to my multiple choice section and I would say, boom, there's my choice. Maybe it says 18.3 and I'm like, oh no, I estimated 18.2. But there's only one choice that's close. Do you see that? So you choose it and then you get it right. All right. Is this too difficult? You understand? This is not a cheat code. This is actually using your brain to solve a problem. All right. And then you can do that much faster than using a calculator. All right. Much faster. What about this one? Where's our normal average? 25. This is an actual element. So we have 25. Which way is this shifting? What's going to be my average? 24.3. Let's say 24.3 AMU. Can you tell me what element that is? We go to our periodic table. This is an actual element. It's not element X. Element X was just used to... Holy smokes, that's magnesium. All right, now... Holy smokes, what in the world happened here? All right, so anyhow, it does not like me making that large. Okay, so now what if I asked you this? Now you know it's magnesium. How did you know it was magnesium? You looked up and you found an average atomic mass, and look, the only one that makes sense is magnesium, 24.3, right? It makes sense. So you know you've identified it as magnesium. Now what if I said, how many neutrons are in isotope 26? How many neutrons? How would I know that? Ah, that's right. I know magnesium has 12 protons. And what's my mass number of isotope 26? 26. That's not difficult. So how many neutrons? 14 neutrons. You see how easy that was? You see how I just took information that we started with, and here we just put it all together, right? And so that's really all you need to be able to do with this topic. And that's really all your worksheet and activity asks you to do so that you can be prepared. All right, with that, I am going to end. I will make sure that you have the answers posted to this and then also a video for how to answer each of these. So make sure you're using these resources. Make sure you're placing units and those type of things in your answers or where they're asked to be shown, because those are things that I count off on, and it's not just me that counts off on them. When you take your AP exam, you lose points on that type of stuff. You will not get credit. So here you know how to do the whole thing, and you didn't put units in, and you get no credit for it. That's not okay. So again, we have to train like we fight. All right. If they're expecting it there, we do it here. All right. So I'm just holding you accountable. I'm just your agent to hold you accountable. But with that, that's all I have for today. Thank you for watching. Please like and subscribe.